It seems like this is everyone's favorite series, and to be honest, it's my favorite series too. I really like working on this application. So let's keep it going. Now, the last few episodes, we've been working on our major index service, all the major index stuff, and we finished up all of that last episode with the major index view model, which we have here. And now that we're finished up with that, I want to bring up our Visio stuff. And so we finished up the major index service, and now it's time to get into some other things. Now, I really want to get some domain logic going, like buying stocks, selling stocks, but to do that, we're going to have to create this iStockPriceService. So that is what we're going to do next. And to do that, we're going to have to use the financial modeling prep API that we used for our major index service as well. So here we are back on the financial modeling prep API website, and the endpoint that we're going to call is this stock real-time price, and they give this example here, so all you have to do is put in this base URL right here and then just append the symbol that you want to search for. So this is Apple, you click this and you get a symbol and you get the price, which is what we really want. So let's go ahead and create the stock price service. We're going to create the interface in our domain layer. So let's go ahead and create a new item in interface. I accidentally named it interface 1, so let's rename it to iStockPriceService. And we're creating this interface right over here. And all we're going to do is make this public. And it's going to have one method. It's going to be a task, so that we can call it asynchronously. And it's going to return a double, which will be the price. And we're just going to call it getPrice. And it's going to take a symbol, such as Apple, which is, I think, APPL or something like that. Make sure you import task. And now we have our interface defined in our domain layer. But now we're going to move into our financial modeling prep API project, and we're going to define the actual service here. And I don't know if I ever mentioned why we have our interface defined in the domain and our service defined down here. And the reason we do that is because we want our application to depend on the interface in our domain layer and not have a very hard dependency on this financial modeling prep API. So basically, what that means is if the financial modeling prep ever disappeared one day, it's not like our application would heavily depend on it. We're really just depending on this iStockPrice service. But we would have to find another source for stock prices, so that could be a problem, but hopefully we won't face that problem. So let's create this new class. We're just going to call it the stock price service. And it's going to be a public class. And it's going to implement the iStockPriceService that we defined. And let's stub that out, import our interfaces, and let's make this asynchronous. And there we go. So let's take a look at our major index service, because we're going to use a lot of this code, and then we're also going to have to refactor so that we don't duplicate code. So to do that, let's actually get rid of this. We're done here. Sure, we can save that. It's full screen. And actually the first thing I'm going to do is I'm literally just going to copy and paste all of this. And let's just move it right in here. Now let's import all this. And we don't have this getURI suffix anymore, so we're not going to be using that. But what we are going to be doing is we're going to be appending the symbol. And then our endpoint is going to change. Let's go ahead and grab that. So I have that right here. I'll try and put that in the description like that. We can get rid of the apple at the end. And we're going to do the same thing. We're going to get an HTTP response message from this endpoint, get it as JSON, deserialize it as, we're not going to deserialize it as a major index anymore. What we're actually going to have to do is create a new object to deserialize the JSON into. So what I'm going to do is I'm going to create a new folder, and we're going to call this results. And inside here I'm going to create a new class called stock price result. So the reason I put this class in the financial modeling prep project and not into the domain layer project is because the rest of the application doesn't need to know about this object. We're only using it to deserialize the result from the API, which is unlike the major index object, which is in our domain layer, which needs to be used throughout the application. And what this class is going to have is just properties that we can deserialize our response into. So let me bring up the API again. And when I click this, we have basically two properties here, symbol and price. So we need to replicate these names as properties on our result object. Now I don't really want the symbol, I kind of just want the price. So what we're going to do is I'm literally just going to create one property on here called price, and it's just going to be a double. And that's all our stock price result needs to be. So now if we go back to our StockPriceService, what we can do is we can deserialize into a stock price result. Let's go ahead and import all of this. And it'll automatically populate that price property with the result from the JSON response. And this isn't a major index anymore, this is a stock price result. And we'll call it stock price result. And then all we're going to do is return the price. And there we go. So now we have two services, the stock price service and the major index service, and they both call the financial modeling prep API. Now the issue here is that we're duplicating a lot of stuff between both of these services, such as the URI, so everything up to this v3 is duplicated between both of these URI strings in our services, and then all of our deserialization is duplicated as well. So what we're going to do is we're going to create a new class, and we're going to call this the financial modeling prep HttpClient. And this is going to be a public class, and it's going to inherit everything from HttpClient. So we're basically just extending an HTTP client and making it for the financial modeling prep API. So what we can do in this class is we can go ahead and create a constructor, and we can set the base address, which is on this HTTP client, and we can set it to the part of the URL that is shared between both of these services. So it's literally just the base address to the API. So let's go ahead and cut this out and paste it in here. And then we can also remove it from here. So now, since we're defining a base address, what's going to happen is whenever we call getAsync for this URI, it's going to automatically prepend the base address to this URI. So now we're not duplicating it between our services because it's just defined as a base address right here. But of course what we're going to have to do is update this HTTP client. It's going to have to now be the financial modeling prep HTTP client. So let's do that for both of our services. And there we go. So now we're not duplicating all of that URI that came between the specific stuff for the services. Now another thing that we're duplicating between our services is all of this deserialization, getting the response as JSON, calling the API. So we can actually create a method on our HTTP client, our custom HTTP client, that does all of that for us. And what that's going to be is a public method. It's going to be a task, so we can call it asynchronously. And it's going to be based on a generic type, because since we're doing deserialization, we want this method to work for any type, so we can deserialize it into any object. And we're just going to call this getAsync, and it's going to take that generic type, and we're just going to take in the endpoint that we're calling as a parameter. So let's go ahead and import that. We need to actually make this async. And let's go into here, and let's just copy this and move it into this method. So same thing, we're going to call the endpoint. We don't have to reference the client. We can just call it getAsync. And getAsync is available because it's on the HTTP client that we're inheriting from. And then after that, we get the JSON. And all we have to do after that is return the deserialized JSON. And we're just going to deserialize into whatever type gets passed into this generic method. And let's import JSON convert. And there we go. So we have all of this logic in our custom HTTP client. So we can go ahead and call it here. So we can say stock price result, equals client.getAsync. And here we go, we have our generic method, and we're getting a stock price result from the URI. And let's go ahead and await that. And then same thing in our major index service. We can get rid of all of that. And now this is just going to be client.getAsync. We're going to get a major index from the URI. And there we go. So now these are a lot more lightweight, and we're sharing all of this stuff due to our custom HTTP client. Now keep in mind, this is a pretty simple approach to calling APIs. One thing you could do is maybe pass in a factory to these services that creates an HTTP client instead of newing it up. But I feel like that would be a little bit overkill in this situation, so we're just going to keep it simple. But anyways, we have our service. Let's actually test out this get price service. Let's just go into our app.xaml, and what we're going to do is we're going to create a new stock price service, and we're just going to call it get price, and the symbol we're going to use is, I think that's Apple. And let's go into our stock price service, put a breakpoint right here, and let's give it a go. So we're loading everything up, and actually we get a JSON reader exception. And the reason, I think the reason that we're getting that is if we look at our URI, I think we need to put a slash at the end. And then we actually have to get rid of these slashes. I've had that issue before. That might fix it. Let's go ahead and try this again. And okay, yeah, that actually makes more sense that the base address has the slash instead of all of these. So anyways, let's look at the price, and we get 0, and we must have typed in the wrong, maybe it's not Apple, let me check actually. It's AAPL, not APPL. It's actually an issue we're going to have to address in a second, but let's make sure that this works with the correct symbol. And there we go. Okay, so it works with the right symbol, but if you have the wrong symbol, it actually returns 0. And the reason it returns 0 is because, let's actually bring up this API, and let me type in the APPL, which is a symbol that does not exist, and as you can see, it returns nothing. And since it returns nothing, when we deserialize that JSON into the stock price result, there's no price field on the JSON to put into this price property. So it just leaves it as 0. So what we're going to have to do is, we don't want people buying stocks that don't exist. So what we're going to do is we're going to throw an exception. So if the stock price result dot price equals 0, we're going to throw something. And we're going to create a custom exception. So this exception can actually go into our domain layer, and we're going to create a folder called exceptions, and we'll call this invalid symbol exception. it's going to be public, and it's going to inherit from exception. Let's generate all of these constructors. I actually don't care about this protected one. And it's going to have a property on it, which is the symbol. And then all of these constructors will take in the symbol. So let's go ahead and copy that into all these. And then inside the constructor, we'll set the symbol equal to symbol. And there we go. Okay, so we have our exception. Let's go into here and let's throw a new invalid symbol exception. And we'll pass in, first we gotta import it, pass in the symbol that they tried to use. And I think this if statement is safe, so if the price is 0, I think we should throw an invalid symbol, because I don't think it's possible for a valid stock to have a price of 0, because then someone could literally just buy unlimited stocks. But correct me if I'm wrong in the comments, because otherwise we'll have to fix this up. But anyways, let's drop a breakpoint here, and let's throw an invalid symbol in here, and let's make sure we're hitting this exception. And there we go. Okay, so we got an invalid symbol. Now, while we're on the topic of exceptions, I was actually looking at this MajorIndexService, and I saw that the default for this switch case right here is just to return Dow Jones, and I actually don't like that. I kind of want to throw an exception here, so that if I ever add another major index type sometime down the road, I don't want it to automatically be calling Dow Jones, because then I might never realize that I didn't implement this switch case. So we're just going to throw a basic exception and say major index type does not have a suffix defined. So that's a little bit cleaner. And now that we're in cleanup mode, I want to show you guys another thing that we can clean up. So if we run this, you guys might have noticed that ideally we want this to say Dow space Jones, and then we might want this to say S and P space 500. But the reason they don't say that is because we're binding that little title text block to this major index type. So it's just running toString on these enum values and just printing these results. And what I noticed was, if I bring up this financial modeling prep API, it seems like they're like updating this pretty frequently. So if I go to this major indexes and let's look at Dow Jones, now there's a property called index name. So what we can do is we can go into our major index and we can just grab that index name now. So it's a property called index name, and now if I go to our major index service, when we deserialize, it's going to fill that index name property, and I'll show that right here. So we get the major index name S and P 500, that is great. So now if I go into our, I believe it's a control, a major index card, instead of binding to the type, we can bind to the index name. And now if we run the application, it's just going to be so pretty. I'm so excited. Oh, get rid of this breakpoint. And there we go, it looks very nice. Now the last thing I want to clean up has to do with our database, and I know we haven't done a lot with our database lately, but very soon we're going to start putting data into the database and interacting with it a lot more. So I want to make sure that our table structure is ideal. And one thing I noticed was, if we look at this object, we named it stock, and stock is on our asset transaction. And the reason I don't like that is because I feel like stock isn't the right name, because down the road we might have an object or a class called stock that has properties such as name of the company, changes, last dividend payout, daily low, stuff like that. And if we have that all on this stock object, that's a problem because our asset transaction actually has a column for each property on the stock object. But we really only ever want our asset transaction object or table to have columns for these two rows. So what I'm going to do is, instead of calling this stock, we're going to save that name for later, and we're going to call this, let me rename it up here, we're going to call this asset. We can rename all references, and then in our asset transaction, we're going to name this property to asset as well. And now what we're going to have to do is update our database. So let's go ahead into our package manager console. I believe we're going to have to set this as our startup project, and let's add migration, and we'll name this migration stock to asset. And I have an issue because I actually reinstalled Visual Studio, so I don't have version 2.2 anymore. So what I need to do is go into my Entity Framework, and you guys can do this too. Let's go ahead and upgrade our framework to .NET Core 3.0, because why not? I mean, our WPF project uses 3.0. Let's do it in Entity Framework as well. So now let's go ahead and try this again, and default project needs to be Entity Framework. Let's add migration again, and there we go. We get our migration, and all we're doing is renaming columns. So let's go ahead and update the database. And there we go. Now if we go into our databases, we have Simple Trader DB, we got tables, asset transactions, columns, and now it says asset instead of stock. So that was just a simple little cleanup I wanted to do just for the future. And even though that rename from stock to asset seemed like a trivial change, I feel like it just makes more sense for the class asset transaction to have a property that is called asset instead of stock, that is of the type asset instead of stock. So it's just all about assets. So we get a little bit of consistency there too. So that's going to wrap it up for this part of the series. So we created our stock price service. We implemented a stock price service in our financial modeling prep API project. We refactored both of our API services by creating this custom financial modeling prep HTTP client. We created a custom exception, so if you try to get the price of a symbol that doesn't exist, then you're going to have to deal with this exception. And then we also renamed our stock object to asset so that we can use stock sometime down the road for a more complicated object and not have to worry about all of the properties of a stock going into the database. So that's going to wrap it up. Thank you guys for watching. I hope you guys learned something from this episode. If you have any questions, comments, or criticisms, leave them below in the comments section. But other than that, leave a like or subscribe for more. Thank you.